What's up, y'all? My name is Mr. Canada and welcome to my math domain. In this video, we're going to be talking about how we can factor expressions by using the greatest common factor of that expression. We're also going to be talking about what factoring is and what the goals of factoring are. So without further ado, let's go ahead and get started. So this is going to be the first factoring video that's going to be uploaded on this channel. So I do kind of want to talk about what factoring is and what sort of our expectations and goals are. So first of all, factoring is the process of finding the factors of an expression. Basically, in a nutshell, what we're going to be trying to do is to figure out what to multiply together to get the expression. So there's a lot of ways you can think of factoring. One example of one way you could think about this is if you ever watched the show Jeopardy. Basically, the whole show is like based around how the game show host gives you the answers and the contestants are trying to find the question that fits that answer. In mathematical terms, basically to us is like given the expression on paper or on the screen, what did the expression look like before any sort of multiplication or distribution happened? So then mainly it's going to be our goal is try to undo that multiplication, that distribution process, and look to see how the problem looked like before any of that math happened. And really, that's what we're trying to shoot for with factoring. There are a lot of ways that you could factor an expression. For example, the main point of this video is factoring by GCF, but that's not the only way. We can also factor by grouping, which will be another video. You could also factor trinomials using the AC method, which again, it's going to be its own video. And there's also special cases in which there are certain factoring rules that fit very, very specific situations. So there's a lot that you can do with factoring. So it's a pretty extensive subject. But just for today, let's talk about how we can factor using the greatest common factor. So let's look at this first example. We have the example 2x plus 6. So how do we actually start the process of factoring by the greatest common factor? Well, here's what you have to keep in mind. First things first, if you want to try to factor by GCF, you first have to find a GCF in the first place. Once you actually find a GCF, then what we're going to do is take that greatest common factor and divide it out of every single term in our expression. Our ultimate goal is that we kind of, like I said, is trying to undo that multiplication process. But in order to be successful with that, we first have to find a number we're multiplying by. So let's go ahead and start. So with 2x plus 6, how do we find a GCF of something like that? Well, here's what you want to do. You want to focus on the 2, and you also want to focus on the 6. So what you kind of want to ask yourself is, what's the greatest common factor of 2 and 6? If you already have it in mind, like you already know the answer is going to be 2, you're right on the money. But if you're unsure about how to find the greatest common factor, let me kind of show you a way you can think about this. One way that you could go about finding the GCF is to make a factor tree for what you have right here, just to kind of have a visualization about what types of numbers you're multiplying by to get 2, and the same for 6. So if we make a factor tree for 2, that'll be 1 times 2. And if we make a factor tree for 6, that's going to be 2 times 3. Now, from here you could see that our tree is very, very small for both of our numbers. But let's kind of ask ourselves, is there a number that they both have in common? And if you see, they both have a 2 in common. And if you can kind of tell, this is the only number that they have in common. So the greatest common factor is going to be 2, because that's the biggest number that both numbers share. So now where do we go from here? Well, now that we've identified the GCF, let's divide out the GCF. So how does that look like? Well, to divide out the GCF, it's actually pretty simple. What you want to try to do is this. First, start off by writing the GCF, and then kind of opening some parentheses with nothing in it. The reason why I'm writing it this way is because it helps us better visualize what's going to be left over after we divide out the GCF. So for example, let's divide 2x by the GCF of 2? Well, 2x divided by 2 is just going to be 1x, or just simply x. Now let's do it with 6. 6 divided by 2 is going to be positive 3, so plus 3. This right here is what we call a factored expression. We can also say that the expression is in the factored form, meaning that it is completely factored and we can't factor it any more than it is. This is what we're trying to shoot for anytime we are factoring by a greatest common factor. Also keep in mind that in terms of our expectations, we are actually multiplying two different types of quantities here. We're multiplying an expression of 2 with an expression of x plus 3. So really this is what we want to see anytime we're factoring. Like I said, when you factor, you might have different techniques and maybe different appearances in your answer, but at the end of the day, you're multiplying two different quantities of something. So let's kind of go ahead and repeat the process, but with this middle example of 5x minus 10. So with 5x minus 10, again, let's kind of think about, well, what's the greatest common factor of 5 and 10? Again, if you do your factor tree for 5 and for 10, you're going to see that a common number that's shared between the factor trees of 5 and 10 is going to be 5. So the GCF of 5 and 10 is going to be 5. Now what we're going to do is take this greatest common factor and start dividing it out of our expression. So to do that, we write the GCF, we open up some parentheses so we know where to put our divided answer in, and now let's go ahead and start dividing. So 5x divided by 5, that's going to be 1x, or just simply x. Negative 10 divided by 5 is negative 2, or in this case, it's going to be minus 2. And this right here is your factored expression, 5 times x minus 2. Let's go ahead and move on to the next one. The next one that we have is x squared plus 2x. Now this one's a little bit different compared to the first two examples that we just did. One thing to notice is that both of my terms in this expression actually have a variable as opposed to just the first term. So how different is our math going to be? It'll be a little bit different, but our approach is going to be the same. What you want to try to do now is try to find the GCF of the variables of x squared and x. So just like how you would finding a common factor for the coefficients, these numbers, you also want to kind of approach it the same way with the variables if it helps you think about it in a certain way. So for example, x squared can be split into x times x. This 2x can be split into 2 times x. Now you want to look at the big picture and kind of ask yourselves, well, between the x squared and the 2x, well, what do they have in common? Well, one thing you might notice is that they both have an x in common. And that's just about it. There's not really anything else that they share in common. So your GCF is going to be equal to just x, which is totally okay. Now from here, what you want to try to do is again, do the same thing with the previous two examples. Write down your GCF, open up some parentheses, and now let's start the division process. Well, since we're dividing out x, we have to keep in mind of our exponent properties. Remember that anytime you're dividing two of the same variable, you're basically subtracting the exponents of the variables. So for example, if you're dividing x squared by x, you're basically just subtracting them. 2 minus the exponent of 1 is going to just be x to the power of 1. Or in other words, you just have an x left over. With the next one, we have 2x divided by x. The x's simplify out, and all you're left with is just plus 2. So this is going to be plus 2. So this right here is your factored form, x times x plus 2. So keep in mind that the GCF doesn't necessarily just have to be a number. Sometimes your GCF can be a variable too. And sometimes it might be a combination of the both. So what's the big idea with factoring by GCF? Well, first you're really just finding the greatest common factor first, and then you're starting the division process of dividing every single term by the GCF. One thing you do have to keep in mind is that not always are you going to have an opportunity to factor out a variable. If not every term has a variable, you can't factor out a variable. You can't factor out an x. Like for example, I can't factor out an x from 2x plus 6 or from 5x minus 10 because the second term doesn't have a variable. So let's look into a little bit more complicated examples, a little bit slightly more complex, and even look into some trinomials, because those can also be factored by GCF as well. So let's look at these guys. So let's look at this first one here. We have 3x squared plus 6x. Notice that this definitely has a lot more pieces compared to the examples we saw above. So let's go ahead and kind of take it a step at a time. Let's look at the GCF of 3x squared and 6x. Well, if you rewrite 3x squared, that's going to be 3x and then x. 6x can be split into 2 and 3 because 2 times 3 is 6, and then just x. So again, what you want to ask yourself is, well, what do they have in common? Well, they have a 3 in common. But is that all? No, they also have an x in common. So in this case, your GCF is going to be 3x. Now we repeat the same process. So after you get a good hang of this, you're basically always trying to keep in mind what they have in common and then dividing it out. So 3x, let's open up some parentheses, and now let's start the division process. So I'm going to take it number by number, letter by letter, just so you can kind of see how the math is flowing. So 3 divided by 3 is 1, and then x squared divided by x is just one singular x. So just 1x or just x is going to be left over. Now let's repeat it with the second one. 6 divided by 3 is 2. And then x divided by x simplifies out. So the x's are gone. So all that's left is just that plus 2 from 6 divided by 3. And this right here is your factored expression. I think I went a little bit too fast on that one. So the reason why this one's x is because 3 divided by 3 is 1. And then when you simplify out an x away from this guy, you're just going to have 1x left over. So really, this is 1x, but I'm not writing the 1 there. Let's move on to the second one here. This is very similar to the first. I'm just kind of giving you guys a lot of examples that you can kind of refer to kind of see the magic happen whenever we're factoring by GCF. So you can see that it's not that bad. Okay, let's look at the GCF of 2x squared and 4x. So 2x squared is going to be 2x and then another x. The GCF of, if we break down 4x, that's going to be 2 times 2 times x. And now from here, you kind of want to look to see what they have in common. Well, they only have one 2 in common, and they have an x in common. That's about it. So they have 2 and x in common, so your greatest common factor is going to be 2x. Now let's go ahead and factor it out. So let's write down 2x. Let's put some parentheses here. Let's start dividing. So 2 times 2 is 1, okay? And then x squared divided by x, well, we just simplify an x out of this guy, so you only have 1x left over. Or just x. 4 divided by 2 is 2. X divided by x simplifies out. There are no more x's remaining, so all you have is just plus 2. And this right here is your factored form. So negative 2x plus 8. So You might be asking yourself, wow, that doesn't look anything like the last two examples. There's a lot less pieces going on here. And you wouldn't be wrong, there is less stuff going on, but I do want to go over it because it is a very special example. So in this case, notice that we're trying to find out the GCF of -2 and 8. One thing you have to keep in mind is that anytime you're trying to factor out the greatest common factor, you also have to factor out the negative number along with it. And this is only true if the leading coefficient, basically the number that's in, the coefficient of the first term, is negative. Notice in all the other cases, the first coefficient was positive, so we never have to worry about that. But in this case, since it is negative, we do have to worry about it. So is that going to change our strategy up? Not really. So again, kind of think about, well, what numbers go both into 2 and 8. And if you do your factor tree, you'll find out that your GCF is going to be 2. But again, like I said, we also want to factor out that negative sign, so this is going to be -2. So let's go ahead and start the factoring process. We put the GCF of -2 out, and now we start the division process. So -2 divided by -2 is +1, and we bring down the x. So really what we have left over is 1x, or just x. +8 divided by -2 is going to get us -4, or just -4. So then this is going to be your factored expression. So you might be asking yourself, is it really that much of a big deal if we don't factor out the -2? Not really, but some of the factoring methods that we'll talk about later does rely on us being able to factor out the negative out of the leading coefficient. So I would say get into the habit of doing so, because it's going to play a huge part later on in our factoring methods. How about we look into some factoring with trinomials? I think that'll be nice to kind of look at, since that comes up every now and then. So what exactly do we have to do if they want us to find the GCF of not just a binomial, but a trinomial? Well, you're going to have to up the ante here, because not only, you don't just have to find the GCF of 2 of the terms, you have to find out the GCF of all 3 terms. So that makes it just a little bit more complicated, just because we do have to consider an extra number as part of our work. But other than that, there's really not much to it. So we have to answer the question of, what's the GCF of 2, 4, and 8? Again, you could totally approach this using a factor tree and checking to see what all 3 trees have in common. And if you do, you'll see that the GCF of all 3 terms is just going to be 2. So all we're going to do now is, again, start the factoring process by dividing out the 2 from all 3 terms. So 2 divided by 2 is 1, so that's going to just be 1x squared, or just x squared. 4 divided by 2 is 2, and we bring down the x, so 2x. And 8 divided by 2 is 4, or just +4. And this right here, for the time being, is going to be our factored form. So really there's not much to it other than just having to consider in another variable in your work. But let's look at the final example of this video. 3x cubed plus 6x squared plus, this is supposed to be a 9x, so you know what, I'm going to go ahead and put a x right there. This is going to be a funny typo later. But 3x cubed plus 6x squared plus 9x. So how do we find a GCF of this? Again, same thing, it's the same process. You look for the GCF of the coefficients and you look for the GCF of the variables. So what you want to keep in mind, again, do your factor tree. And if you look at your number, the coefficients, 3, 6, and 9, you'll see that 3 is going to be the greatest common factor among the coefficients. And among the x's, you're going to see that all 3 trees for the x's only share one x in common. So your GCF will just be 3x. Sort of like what happened with these two. where they only had maximum one x in common. So let's go ahead and start the factoring process by dividing out 3x from all three pieces. So 3 divided by 3 is 1. X cubed divided by x, you're just basically simplifying out 1x, so all you have left are 2 of them, so just x squared. 6 divided by 3 is 2. X squared divided by x, you're simplifying one of those x's, and all you have left is just 1, so a singular x. And then 9 divided by 3 is 3, and you're dividing an x by another x, and when you do, all the x's are simplified, therefore there are no x's left over. So this right here is going to be our factored form. 3x times x squared plus 2x plus 3. Let's go ahead and recap, because this was a pretty long video with tons of examples for you to refer at. But what do you have to do in case they ask you to factor an expression by the greatest common factor? First things first, you've got to find the GCF. If you're good with your mental math and already know what the GCF is just by looking at it, great, perfect. If you're having trouble, on the other hand, finding the GCF, make yourself a factor tree so you're able to see what types of common numbers are shared between both trees. This is also going to be true with the variables. Once you've identified the GCF, now you're going to start the factoring process by dividing out the GCF from all of the terms in your expression. Please take your time whenever you're dividing them out, and always be careful anytime you're simplifying the variables. Well, I hope you found this video useful. If you have any questions, go ahead and leave a question in the comments below, and I'll try to reply as soon as I can. If you liked the video, give this video a like and subscribe to my channel for more Algebra 1 videos. There are definitely going to be more factoring stuff in the future. And as always, please take care, and I'll see you guys next time.